Making life complicated, I have a prop. So, 416, what does that number mean to you? I invite you to think about a large or giant glass container filled with 1 million marbles, of which all are blue, except for 416, which are red. Would you even notice those 416 marbles? Why not, right? But here's the thing. Those 416 red marbles are wreaking havoc in our climate system. And they're presenting us with the biggest challenge of our century, climate change. 416 is currently, in parts per million, in the air that we breathe, the amount of carbon dioxide. And that is the primary greenhouse gas behind our global warming. Using geochemical techniques like those that we've developed in my lab over the last couple of decades, we know that CO2 in the atmosphere has never been this high since humans have evolved. In fact, it hasn't been that high for 3 million years. And in those 3 million years, the Earth has experienced repeated extreme climate changes. In California, these are anomalous climate or weather events like century-long mega droughts and mega floods that made the Central Valley into a giant lake. All anomalous events, but naturally driven at the margins of the climate system. But what really is the take-home point is all with 100 to 200 fewer red marbles in that container. So, how do we know all of this about 3 million years ago and up even to today? We know it from archives of crystallized climate, like this stalagmite that came from a Sierran foothill just an hour or so from here. And if you can see the layers, there are actually thousands of laminations in here, and entombed in each of those is fossil rainwater that was trapped when the mineral layers were laid down each year. And just like the mosquito trapped in amber from Jurassic Park, that has that genetic code of the dinosaur in the fossilized blood, the fossil water in this stalagmite has its own genetic footprint that we can tease out using high resolution instruments. And from the chemical information in these layers, we can extract evidence that are major changes in temperature, in rainfall, in wildfire activity in those past 3 million years, often in sync with major climate change. So today, with up to 200 fewer red marbles in that giant container, humans are supercharging our climate. And thus, any future extreme climate events will most certainly be of greater magnitude than those of the past, archived like in this stalagmite. So that said, I can say I'm hopeful. I'm actually very hopeful. And you should be thinking, why? Because I can imagine a future where we learn to manage our planetary climate, and where climate change is no longer an existential threat. You may not realize, but we are actually in a revolution right now. We're starting to invest trillions in climate mitigation, climate adaptation. The US is leading the way with a recent pledge to reach net zero carbon emissions by mid-century or sooner. And this goal is going to require massive decarbonization in the next couple of decades. And right here at UC Davis, we have leaders who will be involved in the innovation and the implementation of new technologies that no doubt will shift us from the fossil fuel consuming society we are. But my message is that's not going to be enough. We're going to need other ways to decarbonize our world. So imagine if silently in the background, while we develop these technologies, we exploit one of Earth's longest lived and most powerful natural reactions, capable of sequestering billions of tons of CO2 per year, and thus being a part of our decarbonization portfolio. Since this planet has had water, there is a chemical reaction between water and rock that sweeps CO2 from the atmosphere and locks it away in minerals below the Earth's surface. Actually, what happens, rain pulls that CO2 out, it makes carbonic acid, it infiltrates soils and rocks, it dissolves them, and it makes inert carbon that is then sequestered in new minerals for thousands to millions of years. But this natural process is slow. It's on geologic timescales. So at the Institute of the Environment, we see the potential to accelerate that natural process to rates relevant to climate change. How so? We call it enhanced mineral weathering, but it involves adding ground minerals and other amendments like kelp, wherever Ermias is, combining these amendments, adding them to agricultural and rangeland soils, and ultimately to all that land that we anticipate will be decommissioned with climate change. We envision next generation monitoring, coupling it with precision irrigation, where we can define new soil amendment strategies that are tailored to the individual land manager's needs, all while sequestering CO2 from the atmosphere and improving the water and air quality for many rural and underserved communities. So this idea that we can harness the sequestration potential of one of Earth's longest known processes or reactions with minimal new technology, and we can actually remove a good portion of those red marbles from that giant container, is for me reason to be hopeful. Thank you.